Let's continue with last week, okay? We go through the questions like domain, range, piecewise function, asymptote, including horizontal asymptote, vertical asymptote, slant asymptote, okay? And we also learned about solving inequality. We have some good method to solve those kind of inequality. This class we will go through these kind of questions. Right. Let's go ahead. Question 22. How much?
So cosine 5 pi over 6
is here. So how much?
I'm not sure. Sorry, I forgot.
Flip your notes quickly. Find the answer. Or you can draw a unit circle. Let me give you the hint, okay?
Oh, is it sorry, 1/2?
No.
No.
You are 10th grader or 11th grader?
10th.
Okay. If you are 11th grader, you say you don't remember, that's not acceptable, okay? If you are 10th grader, this is okay, but not good. Let's draw the unit circle here. Okay. Five pi over 6. We can say this guy here, this is pi over 6. Pi over 3. Pi over 2. 2 pi over 3. 5 pi over 6. So basically over here, like this, okay? Now, cosine 5 pi over 6 is asking you for the x value. Quadrant 1, 2, 3, 4. All students take class. Cosine here, this is, look, this guy is negative 1/2. This guy here is negative square root 3 over 2. Do you understand now, Brian?
Yes.
Okay. You want to try one more?
Okay. Oh, sorry. So sine for 3 pi over 2.
This is 3 pi over 2, okay?
Isn't that just 0 or negative 1?
Negative 1.
Negative 1. Okay.
Aiden.
Hello. Okay. Tangent of 5 pi over 4 is 1.
One more.
Sine of 7 pi over 6 is negative. What?
Over 4.
7 pi over 4 is negative root 2 over 2.
Very good. Christina. cosine pi.
-1.
-1, very good. This one,
-√3.
-√3. This is excellent. Ling Lu.
Yes.
Wait,
-2.
because cosine. Go
yeah.
ahead. Go ahead.
Because secant equals to 1 over cosine, and cosine of 4 pi over 3 is -1/2.
Okay, so this equals -2, right?
Mm-hmm.
Very good. One more, please.
Pi cosecant of pi over 4 equals to sine of pi over 4. So sine of pi over 4 would equal to square root of 2 over 2. So that would equal to square root of 2.
Yes. You do, hold on, I'm going to call next student, okay? Michelle, number 30.
Cotangent is like the opposite of like tangent,
Mhm.
which for 2 pi over 3 should be -√3. So then the opposite of that is -√3 over 3.
Okay. Very good. Yeah. Most students master what I have taught in this summer, okay? That's very good. Now, we are going to do some more complicated questions, which we already did it over the summer. It's going to be like this, okay? We finished those trigonometry equations over the summer. This is the time to check if you master the skill or not. Okay. Let's start this. Michelle, let's continue to do 35. We can treat this as a quadratic equation. You can use U sub, or you can just use cosine x itself. Which way you want to do?
I guess I'll like substitute.
Uh-huh.
So we'll just say like put it as like 2x squared plus 3x minus 2 is equal to 0.
So we do U2 times U square.
Oh, okay.
Next step.
And then it's gonna expand to like 2x. Well, the way that I do it, I guess like 2u squared plus 4u minus 1 but minus u, and then minus 2, and then I'll like
Like this, right?
yeah.
So U equals?
-2 and 1/2. And then
But cosine U couldn't equals to -2, right?
yeah, so cosine is equal to 1/2. There's like pi over 3. I mean cosine x, like so x is pi over 3. And then also 5 pi over 3.
Very good. Excellent. This is really good. Next one, so then. Let's do 36.
So you have sine squared x equals 1 minus cosine squared x. And so you get 2 times 1 minus cosine squared x minus cosine x equals 1. You get 2 minus 2 cosine squared x minus cosine x equals 1. You get,
Move this to the right, okay?
yeah. Minus cosine x.
No, you put this negative to this side, so it's become positive.
Oh, plus cosine x minus 1.
Uh-huh.
And so,
You put a U, okay?
okay.
Plus.
So we get plus u minus 1. So it's 2 minus u or 2u minus.
So you do here.
Yeah.
It is U plus 1
Times
times
2u minus 1.
Okay.
And it's cosine equals -1 or cosine equals 1/2. And so cosine equals pi, or cosine equals pi over 3 or 5 pi over 3.
Okay, very good. Yeah, you mastered this skill. That's good. Now, Aiden, 37.
Okay, so sine 2 of x is equal to cosine of x. So
What's this formula?
2 sine of x is like
Who is sine 2x?
is that one of the yeah.
Do you remember this formula? Who is this guy?
Sine. Oh, it's sine. Yeah, I think yeah, it's sine a times is it like sine a times
Sine
cosine
alpha.
times cosine of b plus cosine of b times sine cosine of a times sine b.
Alpha, beta, okay? Yeah, like those coronavirus, it's all Greek letters, okay?
So it's
Yeah.
so it would be sine of x plus x. Would you rewrite it like that?
Equals?
Sine of x plus x. Or is that not a step? Yeah.
Oh, take the factor.
Yeah. So wait, factor.
Mhm.
Do you want me to factor this?
Yes.
Oh, right. Cosine of x is factored out, and then in parentheses, it's 2 sine x minus 1.
Okay. Oh,
Cosine, so 2 sine of x equals to 1/2. So that would be so sine of x equals to 1.
what's your answer?
Pi over 3.
Pi over 2. 3 pi over 2, correct?
Yeah.
Yeah, you don't
right.
remember that?
Sine. Yeah, sorry, I was thinking of cosine.
Who else?
5 pi over 6.
Pi over 6 and 5 pi over 6, correct?
Correct.
Hey, not good enough, okay?
Okay.
Brian,
Yes.
do this one.
So it's 2 cosine 2x plus 1. It's 2 cosine 2x equals -1.
Hmm?
Or don't you move the x? Or sorry, the -1 over. Or the 1 into a -1. Right? Yeah, right. Oh, sorry. And then you divide by 2, so it's -1/2.
Okay. Continue.
And then it's cosine 2x equals -1, and you
What? -1/2.
oh equals negative. Sorry, equals -1/2, and then cosine 2 pi minus 2x also equals -1/2.
This equals who? You didn't
Arc
remember
cosine
the
-1/2.
unit circle.
What? 2x equals.
No. You don't remember unit circle at all. Yeah, you need to work hard to cover your unit circle. The very first class, you almost forget everything. You understand now?
Oh, yeah. Okay.
All students take class. Quadrant 2, quadrant 4, cosine is negative. Okay. I'm going to call the next student, okay? Christina.
Yeah.
Because this is 2x, so I should add another value to find the next 2 pair. Go ahead. What should I write down here?
Do you add 2 pi?
Yes, I add 2 pi.
So it's 8 pi over 3 and 10 pi over 3.
Very good.
So x is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3.
Because this is 2. If you have just x, then this 2 answer perfect. If you have 2, you have add 2 pi to here, add 2 pi to here. Because when you divide by 2, all of this will fall in between 0 and 2 pi. That's the answer. Make sense? Brian, does this make sense to you now?
Yes.
You are learning Algebra 2 at your school right now, or you are learning PreCalculus at your school now?
Algebra 2.
Okay. Ling Lu, let's do 39.
Yes. Okay. Could I substitute cosecant for like a variable?
Sure. Go ahead.
Oh, and then plus 3u, and then minus 2 equals 0. And then you could factor that out. So so that would be 2u minus 1, and then u plus 2 equals to 0. So u would equal to -2 and 1/2. And then substitute cosecant back in for u. And then since cosecant equals to sine of 1/2, I mean 1/2,
So this
1
guy
over
will be
sine.
2.
Mhm.
Yeah, and this guy will be 2. Or -1/2, correct?
Mhm.
This is impossible, okay?
Mhm.
So sine x is this. When sine x is -2, x equals
When sine x is -1/2,
Mhm.
that would be equal to oh, 7 pi over 6.
Okay. What else?
11 pi over 6.
There you go. Very good. Now, number 40.
Oh, also me?
Next student.
Okay.
Michelle. Go ahead.
Okay, so tangent, I can replace it with like using one of those like trig identities, right?
Yes. Yes.
Okay, so I guess I'll replace like the tangent squared x to be secant squared like -1.
Good.
Secant squared x minus 1 minus secant x is equal to 1. Yeah. And then secant squared x minus secant x minus 2. And then I guess you can like replace it to have it like u squared minus u minus 2.
Okay.
And then that's like u minus 2 and then u plus 1. And then, yeah, I guess now you can like u is equal to 2 and -1. And then if that's secant, that means secant is equal to 2 and -1. But secant is the opposite of cosine, so then cosine is 1/2 and -1 still.
Okay.
And then for cosine being equal to 1/2, there's pi over 3. So x is equal to pi over 3 and 5 pi over 3. And then -1, x is equal to pi.
There you go. That's
Yeah.
it. Because there is no 2 in front, so you don't need to worry about adding additional. Okay.
Mhm.
Yeah, very good. Number 40. Next student, Suzanne. 41.
So we have cosine x over 3 equals root 3 over 2. So we get x over 3 equals 2 or pi over 6
Good.
and 11 pi over 6.
Yes. There you go. X equals
X equals pi over 2 and 11 pi over 2.
there you go. That's impossible. This is out of 2 pi.
Right, so
So that's it.
Yeah.
That's the answer. Okay. That's good. Aiden. 42.
Okay. So do we use the tangent of 2x formula, the tangent of x plus x or something?
Yeah, so 2x equals
X plus x? Oh, 2x equals to negative root 3.
whose angle tangent equals this?
Oh, so 3.
It's going to be in which quadrant? Quadrant 2, quadrant 4, right?
Yeah.
2x equals?
Oh, is it 2 pi over 3?
Yes. Who else?
5 pi over 3?
This is 2. Can you add another 2 pi?
No.
Yes.
Oh, you can. Then it's
Because after you divide by 2, it's going to be still within between 0 and 2 pi.
oh,
You plus 2 pi. This equals?
that's 8 pi over 3.
Yes. And
11 pi over 3.
x equals?
Yeah, pi over 3 and then 5 pi over 6. 4 pi over 3. And 11 pi over 6.
This is less than 2 pi. So that's it. All of them are correct. Correct?
Correct.
Brian, 43.
So 2 sine 3x minus square root of 3 equals 0. So it's 2 sine of 3x equals to square root of 3. And then you would divide by 2, right? So sine 3x equals square root of 3 over 2. And then 3x would equal to pi over 3. 2 pi over 3.
Very good.
Continue or sorry, what?
Continue.
Oh.
Continue.
All right, 2 pi over 3, 7 pi over 3, 8 pi over 3, 13 pi over 3, and then 14 pi over 3.
Very good. So you keep adding 2 pi. And then this guy add another this is 13 pi over 3. And 8 plus 6 is 14 pi over 6. Correct?
Yes.
And then divide by 3. X equals?
Pi over 9. 2 pi over 9. 7 pi over 9. Huh?
Yes, continue.
Oh, sorry, because that was, okay, sorry.
Yeah, I have a typo, sorry. Continue.
8 pi over 9, 13 pi over 9, and then 14. Huh?
6.
Oh,
No, hold on. I think I did something wrong. This is 3. Okay, I have a typo here. Yes, it's all 3. Correct.
so 13 pi over 9, and then 14 pi over 9.
Very good. Now you mastered it. Okay, that's how we do this question. If you have 3, you are going to adding 2 pi to this, and then you are going to add another 2 pi, another 2 pi. After you divide it by this number, your largest value will still be within 2 pi. Okay, so you have 1, 2, 3, 4, 5, 6. You have 6 solutions. Okay. All right. So I think students in this class all mastered solving trigonometry equations, which is very good. The next few questions, we are going to deal with log and exponential equations, okay? Including the complicated logarithms. Okay. Christina. Let's see 44. E to the power of this guy equals to 37. How do we solve this equation? Have you learned the exponential equation before?
No.
Okay, and let me explain over here, okay? If you say 2 to the power 3 equals to 8, this is the thing you learned before, right?
Yeah.
Yeah, you can rewrite this. You treat 2 as your base. You put 8 over here. This equals to 3. Log 2 of 8, okay, equals to 3. This is saying this is equivalent as 2 to the power 3 equals to 8. Just like plus and minus, they are inverse to each other. Exponential and log are inverse to each other. So using this, can we rewrite this equation?
Log E 37 equals 2x plus 3.
Very good. E is a scientific number, just like pi. E is close to, okay, yeah. It never repeat. It is a rational number, okay? In mathematics, one of the most famous formula is called the Euler equation. Euler equation is saying e to the power of I pi plus 1 equals to 0. Okay. This equation in elementary school, you learned all those natural numbers. And then you start to know the whole number. And in middle school, you start to learn those integers. And you also learn about rational numbers and irrational numbers starting from middle school, like e and pi. In high school, you learn the imaginary numbers. Euler equation is the simplest equation to relate everything you have learned from elementary school, middle school, and high school. Okay, this is the equation which is always correct. And now, when you have e here, you can rewrite. So if you have log ex, you can rewrite this as called ln x. Okay, ln x. So you can see ln 37. And how do you find your ln value? You can do log e. For example, log e of 8. It gives you a value. If you say, I don't like to type in so many things, you can do ln 8. It's exactly the same value. Okay, so far so good.
Yeah.
Now let's solve the x. Go ahead. We can use this minus 3, right?
Yeah.
And then divide by 2. This equals x. Make sense now?
Yeah.
Okay. You do one more question. Here, we are going to do the u sub again. Look. Correct.
Yeah.
So go ahead and replace by u.
U minus 3 times U minus 2 equals 0.
Okay. So who equals to 2?
E to the x equals 2.
Correct. So x equals?
X equals,
Base is e, so you straight write down log e2.
oh, okay.
Okay. Does this make sense to you?
Yeah.
Okay. It's okay. If this is the first time you see this, it takes time to digest, okay? Linglu, 46.
Yes, okay. So first, I would change negative 12e to the power of negative x to negative 12 times 1 over ex.
Let's do this.
Okay.
U equals e to the power x. So e to the power negative x is this, correct?
Mm-hmm.
So this is 1 over u.
Okay.
Now go ahead.
So then that would be u minus 12 times 1 over u minus 1 equals to 0. So then u would equal to
Times u for both, for each term. Times u for
okay.
okay.
So minus 12 and then minus u equals to 0. So then u equals to -3, well, u plus 3 and u minus 4. Then u would equal to 4 and -3. So then that would be e to the power of x equals 4 and -3.
Okay. As exponential functions. Exponential functions, e to the power of x is going to be always above 0. There's no way e to the power of x could be a negative. So this one is going to be gone, okay?
Okay.
From here.
Oh, so then that would be x equals to ln 4.
Good.
Which
That's it. Okay.
okay.
Yeah.
Miss?
Yes.
So for question 44, how do you say the ln? Is it just, or how do you say it?
You call it a ln, okay?
Okay. All right. Sorry, I just didn't really know what to say.
You know, sometimes different people pronounce it a different way, okay? Depends on who teach this class, okay? This guy actually is called a natural log, okay? If you see log of 5x, it's just a log. But if you use a base as a e, it's called a natural log. Yeah. Where is this place used? If you learn chemistry, physics, biology, you use this thing and you use this guy very often. You might heard those terms like half-life, decay, you know. Next student. Michelle. Go ahead, 47.
Okay. So should I like
You see,
divide by 50
this guy will equals to how much? This bottom one equals
11 over 50.
50 over 11.
Oh,
It's okay. If you feel confused, we do this in one more step. Okay?
okay.
Oh.
Yeah.
one more step.
And then subtract like the 4. So then it becomes like 6/11 is equal to e to the power of 2x.
Okay, one more step.
And then like it's like natural log 6/11 is equal
Very
to
good. Very good. Equals
2x.
so x equals.
I can use my calculator, right?
Yeah, it's okay. We leave this format and then you can use your calculator. Okay. Yeah. All right, that's it. Next student. So then 48. Go ahead.
You calling me?
No, Sudan.
Sorry.
Sudan. Look, log AA equals 1. So then, does this make sense to you? Because a to the power 1 is a, okay? Sudan, can you hear me? Susan Lee. Oh, it's okay. Aiden. Look,
Okay,
a
so
to the power 1 is a. So log AA equals 1, correct?
x squared minus 3x equals to, hold on. Yeah, x squared minus 3x equals to 4. So that's x squared minus 3x minus 4 equals to 0. So then it's x minus 4, x plus 1. So x equal to 4 and negative 1. I mean, you have to check it. So do you check it?
Yes. You need
Okay.
to make sure this is positive. Go ahead.
Can I just use a calculator?
No, no, no.
No.
You can do this by hand.
Sure. So 4 to the power of, wait, so 4, and then in parentheses would be, if you plugged 4 in, that would be 16, yeah. So 4 to the power 1 equals 4. So 4 works. And then negative 1 still works because the parentheses is also 4. Negative 1 also works.
Okay. That's good. Brian. Go ahead. X minus 1 equals. Go ahead.
Oh, sorry, my mic. Sorry, e to the power of 3.
Okay.
And then 5, and then you move the 1 over, so 5x equals e3 plus 1. And then you divide by 5, so x is equal to e3 over 5 plus 1 over 5.
All right. That's very good. This is 49. Okay. Next, for question may be a little bit complicated. Christina. Let's do 50. Look at this 50, okay? How do we do this? If you have the same base, okay, for logarithm, there are many properties. When you have here, if they have the same base, that means log 2 x plus 3 times x minus 1 equals to log 2, 12. Okay? And then, hey, Christina, please unmute yourself. Thank you. Christina? No? Ling Lu?
Yes.
Okay. When they have the same base, as actually the product of these two.
Mm-hmm.
So I show students why this is true. This is true, correct?
Mm-hmm.
Okay. We can say let u, okay, let u equals log ax. Let v equals log ay. Does this make sense?
Yes.
Okay. So x u equals to a to the power of u, right?
Mm-hmm.
Y equals to a to the power of v. Make sense?
Mm-hmm.
Okay. So this becomes to log a to the power u. A and y is replaced by a to the power of v. Does this make sense?
Yes.
Okay. And you can tell log a to the power u is just equals to u. Make sense?
Mm-hmm.
Because a to the power u equals to a to the power u, correct?
Mm-hmm.
This is always true. So if you put a log here, then this u equals u. Okay? Make sense?
Mm-hmm.
Correct.
Yes.
Who is u? Who is v? So this is u plus v. And u plus v, let's check over here. We can also see log a x y. Let's check here. Who is x? A to the power u, right?
Mm-hmm.
Who is y? Make sense?
Mm-hmm.
Equals to log a and a to the power u plus v. Make sense?
Yes.
Okay. And you can put u plus v in front because they have the same base of AA. That's why this guy and this guy always equal. Does this make sense now?
Mm-hmm.
So that's why when this number equal, you can times these two together. Okay.
Mm-hmm.
When this guy equals this guy and this base are the same, you will make this equals this. Okay.
Mm-hmm.
Yeah, go ahead.
So oh, okay. So that would, so x plus 3 times x minus 1 would factor out to x squared plus 2x minus 3.
Minus x.
Oh, right. Mm-hmm. And then we would subtract 12 from both sides. So that would be x squared plus 2.
Oh, you are right. I have a typo. Yeah, you already canceled that.
Mhm.
Thank you.
So then that would factor out to x plus 5 times x minus 3. So then x would equal -5 and 3.
Okay. Plugging. You have to make sure that's positive. Okay.
Okay. -5 plus 3 is 2.
-2.
Oh, right. Sorry, -2. So that wouldn't work. And then plugging in 3 would give you 6 and 2.
Yeah, this is the correct answer. Okay.
Mhm.
That's question 50, 51. Christina.
Yeah.
Let's try this 51.
So this is equal to plug A.
This is minus. If it's minus, we will do the
Oh.
division. Look, I'm going to change this guy over here, okay?
Okay.
So everything over here, I'm going to show quickly. So this is u minus v. And if this is minus and they have the same base, you can do the division. So what we do over here, u minus v, correct?
Yeah.
So this guy and this guy are equal, okay?
Yeah.
Let's go ahead.
So it's equal to log 8x plus 5 over x minus 2 equals 1.
Okay. Now we want to solve this. What do you think this should equal?
8.
Good, that's good. You know, I really feel so blessed for having so many smart students in this summer class. Very good. Next.
X plus 5 equals 8x minus 16.
Next.
And then 21 equals 7x. X equals 3.
All right. Double check. Double check. It's working, right?
Yeah.
This is 1. This is 0. 1 minus 0 is 1. Correct?
Yeah.
Okay. Let's do next one. For 52, you have a very long chain. If you do this question layer by layer, you see some hard question. Don't feel panic. Say, I'm not able to do it. You want to see what's the out layer. What can you do first? Michelle. Guess who is this?
Mm,
6 to the power 0 equals
1.
1. So this equals to 1.
Oh, okay. Yeah.
You know, very often they say, oh, in high school, girls cannot do better than boys. Not true. We have so many smart girls in this class. Look at this one more time. Who is this?
0.
Mm,
Oh, wait. Oh, is it just like, oh, it's 4?
when this base and this thing are the same, this will be 1.
Yeah.
Just like here. If this is 8, this is 1. If this is a 4, this is 1. Make sense? Okay. One more step, and the last step.
If it's like 2 to the 4, so it's 16.
Yes. There you go. Perfect answer. Make sense now?
Yeah.
Okay. Suzanne Lee. Can you hear me?
Yeah.
Okay. I don't know why just now you didn't unmute yourself.
Oh, I'm not sure. I did number 51, right?
Let's do this guy.
Oh, okay then.
Who is this?
2.
Good. That's beautiful. Who is this?
1.
Yes.
So it's 0.
Very good. Perfect answer. Okay. That's nice. So this is 53. Now we are going to see some words problem. This is just like a coronavirus question. Okay. Yeah, you can change the question, say the number of students in a school infected by the coronavirus T days after exposure is modeled by this. And they ask you how many were infected after 3 days. And they also ask you, when will 100 students be infected? This is a calculate question. What do? You plug in 3 into here, and then you will be able to have the answer, okay? This model itself is called a logistic model. You will not learn this logistic model until you learn the calculus BC, okay? So right now you don't know, you don't need to know why this model is like that. You will revisit this called logistic model in BC calculus. Right now, you just plug in, okay? Everybody go ahead, type in your calculator or your graph calculator. Find out P3 is how much. And then also use your calculator. You want to make this guy equals to 100. And you find out T equals to how much. Everybody go ahead and do it now. You can text me in the chat window about your answer A and answer B. Don't text me until you finish both A and B, okay? Text me A, answer, B, answer. Very good, Lindu. You can try number 55.
Sorry about that. I accidentally sent it to
Oh.
everybody.
Okay, that's fine.
Sorry.
It's okay. It's okay. Yeah, the good thing that you learn this kind of question right now is because if you are taking AP chemistry this year, you know you have to deal with this kind of question very often, right? Okay, Michelle, you can work on 55 also. No, that's fine. Okay, Brian, that's right. You can use graph calculator to find how many days once 100 students be infected. Yeah,
For
you know,
the calculator, is it okay if I use decimals or?
Yeah, you can use decimals. What you can do is, let me show you how do we use this in decimals. You do this, okay? You do 300 over 1 plus e to the power of 4 minus, you cannot put t because they don't recognize t, they only recognize x and y, so you do x, okay? 4 minus x. And you want to see this guy reach to it, 100. So you are going to push down this, and you can see, hey, my y is a constant 100. Where do you meet? There. So this is 3.3 days. Okay. Brian, does this method work for you?
Yeah. I just put it in and got.
So if you don't like to find the crossing points, you can also do this way. You can say, I'm going to minus 100. And then I'm going to just look for the points where it reached to the zeros. What's going on? So you either do this way. What's going on? Okay. Oh, because I didn't type in y equals. Yeah, so you look for these crossing points. That's how you solve by how many days you reach the 100 students got infected, okay? Yeah. If you push this, if you squeeze this model, okay, after certain days, the amount of people who get affected is going to be flat, okay? Just like recently, the Delta variant are so crazy and the slope goes so steep. To a certain point, it's going to be flat again. So everybody is expecting a inflection point, okay? That's why learning math is important. You can use math model to learn very complicated questions. Okay. Everybody finish 54? Yeah, almost everybody get 54 correct. And some students even finish 55. Linglu, go ahead, explain how you did 55.
55.
Mhm.
Okay, so since for the function it gives you n0, which is 500, but it doesn't give you k or like the rate it grows by. So you have to figure it out by doing 1,200 equals to 500e to the power of k
Okay.
times 1, since it's after 1 hour.
Okay.
So then if you solve that, k would equal to ln of 12/5, and that would be a rate.
Yes.
So then to figure out a, you would substitute t in for, you substitute 4 in for t. So that would equal to 500 times e to the power of ln 12/5 times 4. And that would equal to 1,688 bacteria. I think the answer was like, I had a 0.8, but you wouldn't count that since that's not a whole bacteria.
Okay.
And
So-
then,
Hold on. Okay, yeah.
Mhm.
So basically, we put in calculator about this, correct?
Mhm.
Okay. So let's just verify here. This is 500 times e to the power of ln, and 12/5 is 2.4, and then there times 4, correct?
Mhm.
Okay, so that's the first answer. And then the next one, we need to solve that guy reach to 8,000, correct?
Mhm.
Okay, so what we do is we do 500 times e to the power of k is ln 12/5, and then times x. Okay, like that. And we are looking for when this guy will reach to 8,000, right?
Mhm.
Okay, and then we are looking for the crossing point. So I'm going to squeeze y directions. And there, solving this, correct?
Mhm.
We get the same answer.
Yes.
Okay. Okay. T equals to this. Okay.
Mhm.
So in both questions, part A is giving a given t, find the y. Part B is given a y to find the t. Okay. If you have a TI Inspire CAS, if you have a TI Inspire CAS, let me show everyone this one. Another fast way, okay? If you have a TI Inspire, you can do this way. You can click menu, and you can do algebra. And there is somebody called a solve. This solve can solve some really complicated equations. So you just do 8,000 equals 500 times e to the power of ln 12 over 5 is 2.4. And then times x. So you type in this guy there. And then you do a comma. And then because the one you want to solve, the one variable you want to solve is the x. So you type in x and then you enter. Okay. Using this way, you can do you can get the solution very fast. Okay. If you have a TI Inspire, CES, not CX. Okay. There are two different versions for the TI Inspire. One is called CES. The other is CX only. Okay. Their price difference is about $30, but CES is really advanced. It's going to be very helpful for you to take the SAT and the PSAT and ACT. All right. Is there any question for 54 and 55? No question? Okay. I'm going to explain the next question. It's called optimization question. Question 56. Okay, let's see here. Michelle, please read this question.
A rancher has 200 feet of fencing with which to enclose two adjacent rectangular corrals as shown. What dimensions should be used so that the enclosed area will be a maximum?
Okay, so we can make this as x, and this piece as y and y and y. Okay, they give us totally 200. That means y plus y plus y plus x plus x. The total length is 200 feet. So we write down this. And this is a restriction. The question for the optimization is asking what dimension should be used to enclose those area to reach to a maximum. The area is a rectangle, correct, Michelle?
Yeah.
So your area will be x times y. And then your y can be rewrite as 200 minus 2x over 3. So this guy is going to be the function. Does that make sense?
Mm-hmm.
Okay, now everybody, you learned completing square before. You can also go ahead and use your calculator. Find the maximum for this guy. Everybody go ahead and then text me your answer, please. Find the maximum of this one. What's maximum for this value? Who finished? This guy's maximum. This is a parabola. It is opening down. So it's going to have a vertex. Okay. The vertex y value is going to be the maximum value for this expression. In PreCalculus, optimization part is the places where students get very low grade, okay? But if you know the trick, the steps is like this. Read this given condition, draw the figure, mark the geometry variables based on this figure, writing down your equation. And then look for who is the guy you want to optimize. The area here is the guy you want to optimize. So you want to write down the area expression. The area expression after you write down, you want to get rid of one of the variable. You cannot mix this for x, y. You have to replace this by x so that you can find out this function's maxima. And then you see this is a quadratic function, easy. You can do completing the square to get your maximum. So your maximum is this. So which is saying when your x is going to be 25, your area will be the maximum, which is this. Okay. Next year, when you learn calculus, you will find out for a function, if you want to reach your maximum or your minimum, you will do the first derivative, make it equals to 0. And when this guy, when you make this equal 0, you find your x value. And then you can plug in the x value into this expression. You will find out your maximum. Okay. So basically, that's the steps. I will show all my work on the Google Drive link. Okay. That's for today's class. Now, today is the last class for this whole summer, PreCalculus. I do appreciate everyone works so hard and learns a lot.